Hello, this is Alex. This is a battery for the ORCASat electrical power system proof of concept prototype. It's a single cell lithium ion battery. Sorry, my big fat hand's in the way. It's a single cell lithium ion battery that has some protection and control circuitry on it. So what I have here is I have a power supply. This is supplying a 3 volt and a 4 volt signal. The 3 volt signal is basically just the battery enable / disable signal. This would come from the power system regulation control circuitry. The 4 volt signal is basically acting like a solar panel. So this is a current limited source. It's not current limited right now, but it's a current limited source to about 500 milliamps, I believe. And it acts like a maximum power point tracker solar panel type of deal. Over here we have an ammeter, and this is measuring the current into and out of the battery. So negative sign means current in, positive sign means current out. So right now we are charging the battery at about 3.5 or 350 milliamps. And then here we have a DC load. So this acts like the satellite. So the load is in parallel. This is all wired up like the power system topology would actually be. Of course, there's no regulation, power regulation or power distribution component. It's just a DC load, and there's no generation component. It's just a power supply. So the first thing I'm going to show is current into the battery is 350 milliamps. We are, a little bit off because these are not really calibrated equipment and they're kind of crappy, but you get the idea. There's about 300 milliamps going in, 350 milliamps going in, and it's saying it's supplying about 350 milliamps. If I turn this down, so if I basically disable the battery, if I decrease this, you can see the battery is now disabled. There's no current going in, even though the source is still present. There is no current going into the battery. If I bring this back up to about 3 volts, you can see the battery is now charging again. So that's part of the nanoracks requirements. The switch is essentially the solid state relay here. It's on the low side, so it abides the nanoracks requirements, and that control signal would come from the 30-minute timer to enable or disable the battery pack. So let's look at the charging really quick here. So if I have a 4 volt signal, which is basically the output of the maximum power point tracker, and it's applying 380 milliamps. If I apply a DC load to this, so this is my DC load, I'm just going to up the current. It's just in constant current mode. If I up the current, that was a bit extreme, sorry, ignore the screen. If I up the current here, this knob is really finicky. Let's say 300 milliamps into the load. You can see that it is now supplying 500 milliamps. It's now current limiting, so it's dropping the voltage a little bit. So it's 3.9 volts, current limiting, and it's applying 550 milliamps. So you can see 300 milliamps is going into the load, and 200 milliamps is going into charging the battery. So that adds up. And if I keep on increasing the current, you can see that the supply is the one that's supplying the load, and what it's doing is it's decreasing the current into the battery to supplement the increased current into the load. And if we keep on increasing this, we will, whoops, sorry, a little bit of a spoiler alert there. You'll see, okay, there we go. So right at 500 milliamps, we are now getting basically 0 milliamps into the battery. So the battery is just sitting there. It's not charging, nor is it discharging. And if we keep on increasing our load to about an amp there, you will see that now the battery is now discharging. So now it's discharging 460 milliamps, and this is supplying 500 milliamps, which then adds up to what we're seeing there. Now, of course, the numbers aren't quite right because these are not calibrated test equipment. And if we keep on increasing this, so now we're at an amp, you'll see now that this is still supplying the 550 milliamps, but this guy is now going to start supplying, the battery is going to now start supplying most of the current. If we keep on increasing this, you'll see it increases, supplies current, supplies current, supplies current, and you'll see that once we reach about 750 milliamps, boom, there we go. So now it cuts off. So now the battery has been disconnected, it's been isolated, because discharging more than 750 milliamps triggers the protection circuitry. And the reason why we're doing that is because, well, 750 milliamps is kind of an easy number to work with, in the sense that if your battery is super cold, you can discharge 750 milliamps out of it and not have to worry about any sort of temperature control. If we had temperature control like heaters and whatnot into the satellite, that will be increased, but for now, it's 750 milliamps. So as you can see, the load has crashed. So the supply has crashed to 2.3 volts at 300 milliamps as expected, because it can't supply anywhere near the amount of current it's supposed to. It's only supplying 300 milliamps. So if we back the load off, so the load goes away, and ta-da, we can now see that the voltage comes back. So now the solar panel is able to supply the load, and it's in constant current mode, supplying 550 milliamps at 3.8 volts, and it's supplying most of that's going into the load, and a little bit is going back into charging the battery. We have a 4-volt signal, current limited to 500 milliamps. It's not current limiting right now, it's just a constant voltage mode, and we're charging the battery at about 400 milliamps there, and we don't have a DC load anymore. What we're going to do is just do a short circuit test. So I'm going to use this little jumper, and I'm going to short the load. And as you can see, the load is now shorted. The supply sees the short, so it's dropped the voltage to 100 millivolts, and it's supplying the full 550 milliamps. Now what's really interesting is there's no current coming out of the battery. The battery is completely isolated. So we can actually just sustain the short for indefinitely, and the battery will never see the short. So the battery is not getting warm as expected, and none of the control circuitry is getting warm, although just shoving my big fat finger in there isn't a really good test. But yeah, basically what's happening is the protection circuitry is opened. There's no voltage across the battery. If I had a voltmeter, which I do right there, but I only got one pair of hands. If I measured across the battery, it would read 0 volts. It's essentially open right now. And if I remove the short's removed, jumper's pulled off, we can now see that, hey, the battery returns back to the state. So we also got short circuit protection.